on this question here, what I really want to focus on is just the information that we can pull from this, what we call Minitab computer output. And so you can see from the top right here that this is a test. Use a different color. This is a test of P equals 0.75 versus P not equal to 0.75, which is telling us that this is a two-tailed test. Okay, you have here your X equals 0.68. X is the number of successes, the number of whatever it is you're looking for, right? The N that's given here is your sample size. Okay, you have your sample P, which is your P hat. You have your confidence interval. You have your Z-score, or the Z statistic, and then the p-value at the end. The only thing that we don't have here is our alpha, or our significance level, which is going to be 0.05. Because we're looking at the 95% confidence interval, then that means there's 5% left for the outside, which is our significance level. In section 9.1, we talked about two different types of errors. We talked about the type 1 error, which was rejecting the null hypothesis when it's true. And we said that the probability of this type 1 error was equal to alpha, which is our significance level. In this section, we're looking at mostly type 2 errors. And so we know that a type 2 error is when we fail to reject the null hypothesis, but it's actually false. And so the probability of a type 2 error depends on a lot of different things, and so it's often difficult to calculate. We would note the probability of a type 2 error as beta, right, which is this Greek letter that's kind of like a B, but you're not going to be asked to calculate that by yourself, by hand, okay? It's more common instead to report the significance test rejects the null hypothesis when the alternative is true, and we call this probability the power of the test, okay? Power of the test has to be a number between 0 and 1. A power close to 0 means the test almost never finds that the null hypothesis is false, and a power near 1 tells us that the test is very likely to reject the null in favor of the alternative when the null is false. Okay, the significance level of a test is the probability of the wrong conclusion when the null hypothesis is true, and the power of the test is the ability to come to the right conclusion when the alternative is true. Now, the power of the test, if you had to calculate that yourself, you would be calculating 1 minus beta, okay? The most important thing here is really how to increase the power of a test. And so one way to do that is to increase the sample size. A second way is to increase the significance level. We can increase the difference between the null and the alternative parameter values. We can make good choices when collecting data, like using blocking in an experiment or stratifying in a random sample. And of course, the best thing we can do is to choose an alpha level that's as high as we're willing to risk, and a sample that's as big as we can afford. And so if I look at this last example here, and we're referring back to the potato chips, where we had said we had a null hypothesis of being equal to 0.08 and an alternative hypothesis of being greater than 0.08, okay? So in this case, it's asking which is the most serious for the potato chip producer, a type 1 or a type 2 error. And we're going to say that a type 2 error is most serious because that involves us making making bad chips. And so because the type 2 error is the most serious, we're going to choose the largest significance level possible, because a greater significance level is the same as choosing greater power, which is specifically related to the type 2 error. Okay, then which of these, or what's going to happen in each of these scenarios? If you change the significance level to 0.10, it increases the power. If you decrease your sample size, you're decreasing your power. And then finally, if we look to detect 0.10 instead of 0.11, our alternative is getting closer to the 0.08 that we're looking at, so this also decreases the power. I apologize for my voice, and I hope you were able to understand. Homework is due on Wednesday, and on Wednesday we'll continue with 9.3.